Hi, good afternoon all. Sorry. Oh, should be morning. Sorry, I'm late for 12 minutes. Sorry about that. Can you hear me? I'm still in Taiwan actually, so I'm so sorry for that. Let us continue the class. I'm I will I try to shorten up the content of the lecture. Okay, so maybe the material that I sent to you, it contains a lot of information, but some of them maybe it is to me, maybe it is not very useful to you. From now on, I just would like to focus on your test. Okay, focus on your test. So as all of you would like to have the test on next Wednesday, correct? Because all of you agree that you want to have a test on next Wednesday. So meaning that I have to speed up the class because we learn very little and then you want to have tests already. So it's like, oh. So everyone agree that you want to have tests on 8th November, Wednesday, correct? And already from the e-learning platform. I just uploaded one of the lecture. Actually, I want to upload another one, but anyway, we'll see how it goes. So, okay, give me some time. Wait, I need to do changes. Okay, so I will. Uh-huh. Oh. Okay. Right. So I have uploaded this note in the e-learning platform, and I plan to then we will have quiz in the e-learning platform tomorrow as well. The quiz in e-learning platform. Okay, I'll try to make a simple quiz tomorrow in the e-learning platform. Okay, so get ready tomorrow to enter the e-learning classroom. Okay, so now we continue the class that we finished the very introductory part about the composite. So we are going to learn about polymer composite in more specifically. So what is polymer matrix composite? I think every one of you have known is the matrix come from the polymer. So it can be many types of polymers. It can be in rubber, thermoplastic, thermoset, all of them. Okay, so that we also know that, okay, the major disadvantage of the polymer matrix composite is it has a low thermal resistance. So it same goes to that we do the differentiation between polymer, ceramic, as well as metal. In our physical class, then we know that they are different. So am I finished this part, girls? I think, okay. So I will speed up. They are the same because the major ingredient is the polymer. So they will be the same. Like the disadvantage is come from the polymer itself. However, we still can improve the thermal resistance of the polymer by incorporating those particles, those materials, which, how can I say, which has a high thermal stability, which is high thermal stability. Okay, example like those inorganic materials. So it become organic, inorganic. Then we also learn that if you would like to, example, sorry, is if we would like to have just now where I stopped. Okay, so we are incorporating the organic and inorganic material together. Then actually we need help from a material like we say coupling agent, compatibilizer that we learn when we are together, right? So please let me know if I have taught this to you. I think yeah, no, right? Okay. And now come to this part, no? We talk about rule of mixture. Okay. So this is important. Okay, this is important. In the traditional polymer composite material, then we apply the rule of mixture. So it is usually used for the fiber reinforced composite, meaning that it has example for the long fiber. Okay. We are gonna to learn it at the third topic when specifically for fiber reinforced polymer composite. So from the rules of mixture, it helps us to estimate, just to estimate. It's, you can't, actually it's not for us to get the exact result, but to help us to do the estimation. So to know about the modulus of the composite, the tensile of the composite, okay, modulus, the strength, okay, regardless, maybe tensile, not tensile, but modulus, strength, elongation, okay, and also the density. Okay, so these are the four information that we can that we can rule of mixture, meaning that it's an equation. There is a equation based on the orientation of the fiber. Either it is unidirectional, perpendicular, or transverse. So we will learn that later a little bit. Not very difficult. I will give you a simple example. Okay, simple example. So then we can predict, no? We can predict those information that I tell you, including the density of the composite, the density of the composite. Okay. Reasons for the use of polymeric, of course, we know that because it is polymer composite is lightweight. The weight is very light. Okay, lightweight. Wait. Okay, so it is lightweight. Then that is the major advantage of having the polymer composite. The rest, maybe we can overcome it. I mean, the disadvantage of the polymer itself, we can overcome it with incorporation with other organic or inorganic materials. Okay. Okay, so here is just our, you learn this, right? You learn this in your first year. What is the definition of polymer? You learn this in the first year. What is the definition of polymer? So you have learned this one. So I will not repeat. I will not repeat. So, and the structure of the polymer, it consists of amorphous and polymer itself. Okay, I ask one question. Is polymer, can we find right now, but I'm not saying totally it is impossible. Sometimes it can be possible. But my question is polymer, we can get 100% polymer in the world or not right now? Is there any 100% crystalline polymer in the world? So far, no, right? So, so then that's why we have only categorize the structure of the polymer into two. One is the amorphous, another one is the semi-crystalline. So the highest crystallinity of the polymer that in the market right now, I can say is about 70 to 80%. So the 20 to 30%, they are still in the amorphous. Okay, so you know about this. Okay, then maybe I actually also tell you some of the special feature, right, of these two structures of the polymer. Okay, which type of structure of the polymer has higher strength, amorphous or semi-crystalline? You can type
Semi.
semi. Okay, so you can type your answer as well if you want. If you if you don't want to talk like Jaime or Jeff, no. Okay, so now here there is some dilemma happen. We know if semi-crystalline polymer high strength, okay, and also usually it has a high molecular weight. So you learn about molecular weight, correct? You learn about molecular weight. High molecular weight were actually high molecular weight will actually give a high strength. However, the viscosity of the polymer is high. It's difficult to be processed, but the property is better. So this is the dilemma that I mentioned here. So you see high molecular weight, you have a high mechanical properties in terms of strength, okay? However, with the low molecular weight, you have low, okay, you have low, example here, no? You have low mechanical strength, but it is easy to be processed because the viscosity is low, so you don't need to have to use so much of force and high temperature to produce it. So we are in the dilemma of this situation. In the process part, of course we love this one. We like the low molecular weight, but in the property side, we like high molecular weight. So what can we do? So we have to compensate, meaning that compensation is very important. We have to choose in between. Yeah, to me, it's like we need to choose in between, not very low molecular weight or not very high molecular weight. So in between, then we'll get something that we want. That is, we call, this one is the great dilemma of the polymers. Okay, so I will just pass over here. And that is one that we mentioned about the thermoplastic, right? So how about the thermoset? Usually thermoset is in a liquid form, correct? So we have not add any close linker into it, or we call it hardener. Okay, in the laboratory, do you deal with any example thermoset like epoxy in the lab before, and then you calculate the gel time and whatever those, I think, but you are in this what do you call it, the pandemic season. Have you do any lab dealing with thermoset? Yes, also good. Okay, so thank you, Jeff. So you have deal with this thermoset polymer. So you will know thermoset is the viscosity is very low, right? Unless you add the hardener, then it close link, then only you can't process it. So that's good. So dealing with thermoset is a little bit, somehow I can say that is an easy part of it, and it is also a difficult part of it. Difficult part is once it is close link, you can't do anything because it is a reversible process. It is non-reversible process. Sorry, it is a non-reversible process compared to thermoplastic. Okay, so for the thermoset, there is no compromise. We don't have to compromise like the thermoplastic that I mentioned just now. So because the initial ingredient is all in liquid form. Okay, so unless then we only control the amount of the hardener or the amount of close linker then during the process. Okay. Hi. So you know about these thermoset is a closed-link structure. Thermoplastic, some of them is in a linear structure. Then they are bonded by the covalent bonds, something like this. So I will not repeat, but somehow maybe in the test I still will ask you to do the differentiation. Okay, to do the differentiation between polymer composite, ceramic composite, and this metal matrix composite. So maybe it's your exercise or something, but I still have to think of it. Okay, I will not repeat this. This is natural rubber, thermoset. You are very, very familiar. So I would not repeat the same thing. So for the elastomers, we are very popular for this natural rubber, right? So natural rubber is kind of popular. Hold on, kids. Let me do something very fast. Okay, so we have this type of different type of rubbers. It can be come from natural rubber, isopropylene. How many of you use natural rubber in your FIP? Got any? How many of you? None. If yes, please respond. If no, keep quiet. If no, keep quiet. If yes, please respond. Yes or no? Let me check. It seems like no, right? No, huh? None of you, no? Okay. Right, none of you. Okay. So never mind. None of you is fine. Okay. So here the thermoset. Okay, thermoset, we know it very well. Thermoset is in liquid form, and then when it is closed link, we add the hardener, then it is non-reversible. Okay, so you know about the difference between the thermoset and also the thermoplastic, right? So I will not repeat. It's just for your this what we call it, for your reference, maybe. Okay. Okay, so keep repeat the same. Okay, now this one. I want to ask a question from this part. Okay. What is mean by pot life? Because in the thermoplastic, we don't learn about this pot life. Okay. So when our kids, let me pick up the phone for a while, okay? Oh. Okay, never mind. I'll call back later. Okay. So what is mean by pot life? What is mean by pot life? Someone has typed it. Jeff, how much time it can be stored? Lifespan during store. Jeff, how about shelf life? Is shelf life and pot life the same? Okay, another question. Is shelf life of thermoset and pot life of thermoset are the same? Okay, first question. You heard about pot life and shelf life. Now this one is pot life, shelf life, right? Jeff say not sure. Okay. Or do you learn this in your first year or second year? Huh? Wait. Okay. So second, shelf life. Okay. Honey say, Farah Honey. So Farah Honey. So I can say Honey. So Honey say shelf life is a period during which product can be stored under specific condition. Okay. Shelf life is a storing of the final product. Okay. So pot life. So what is pot life? Then Honey say amount of time mix prepared during remains in a suitable workable state once it has been combined or activated. Hanis, are you meaning that this is spot life? Very good. Hanis has mentioned this. Hanis, are you here? For Hanis. So I call you Hanis lah. Can you speak? Maybe I want to listen your voice. I'll see you guys next week, okay?
Yes, doctor.
Yes, okay. So thank you, Hanis, for giving the accurate answer. I think you Google it or what? Something like it is very similar to like a Google, no? Okay, good boys and girls. Very happy to hear that. Okay, so remember that one. Remember that one. Okay, remember that one. Do not forget. Okay. Now the rest, I think it is quite easy for you. No? Okay. Well, these are all about the properties of the thermoplastics. No, I'm not going to like repeat. Also, it's kind of boring. Too many words inside. And then this is rubber. And then this is the, what we call, the comparison between only the polymer. See, the MOSFET, this is the MOSFET naked. This is thermoplastic. So the modulus of the MOSFET will be slightly higher, I can say, compared to thermoplastic. However, the fracture toughness is lower compared to the thermoplastic. Okay, kids, we're gonna to learn fracture toughness, but I remember some your seniors has been learn this with I can say Dr. Te. So you remember this one, fracture toughness? Any one of you get the idea that, not the idea, I mean, still remember you have learned this fracture toughness? Yes or no? Have you heard this term, fracture? This one, fracture toughness. No, Jeff say no. Okay, who else? Who else? Please, I need more response. Aside, I know usually Jeff, Chaime, Honey's quite active. How about the others? Esther also say no. Okay, fracture, yes. Fracture toughness, no. Oh, okay, okay. It seems like you learn not much, compared to your senior, because in the past years, your senior has told me that they learn fracture toughness a little bit from Dr. Tan. I think maybe during the third year time in the subject with Dr. Tan. That quite okay. It sounds a little bit weird, no? You didn't learn this, no? Okay, I actually have something to show in in the lecture in our next class later. So our next class, I will speed up the next class, because next class will be, the next topic will be about types of materials that you can add, or types of fillers that you can add into the polymer matrix. So I will just focus a few fillers which they are important in your test or exam. Now, well, you know about this already. Thermoplastic is recyclable. Is you can keep reproducing it until the polymer chain getting shorter and shorter and shorter, something like that. No, okay. So these are okay, kids. Remember, do not follow this example. Okay, wait. Do not follow this example. Okay, if I ask you to do comparison, okay, if I ask you to do comparison, you don't follow this example. This is not a good example that I show you in my notes now. So example, I want you to compare thermoset and thermoplastic. So here you have higher, you should write high. For thermoset, it has higher thermostability. For thermoplastic, here you should write lower thermostability. So compare like this, thermal, compare with thermal, chemical resistance, compare to chemical resistance. So like for here, a thermoset has a higher thermal resistance, meaning that another one at the side here, you should write lower chemical resistance. So compare like this, okay? This is a bad example. This is a bad example. I'm sorry for that, but I just want to tell you that majority of the students, when they give me the answer, especially for the comparison part, they will do like this. So this is not a good comparison, okay? So if you have 5, thermal, strength, chemical resistance, what else? Maybe storage life, no? Shelf life, but shelf life only happen to thermoset. It doesn't occur for, not shelf life, pot life, no? So it doesn't happen to thermoplastic. So don't compare because they, you know, they are uncomparable somehow, okay? So tackiness, okay, so you can say thermoplastic is no tackiness, but thermoset is tackiness. Yeah, so like this, side by side, side by side, side by side. Okay, so this is a bad example. And then thermoset is non-recyclable. You put here non-recyclable. Thermoplastic is recyclable. Yeah, something like that, okay? So make it clear. Make a table and then column and then, no? Clear? Are you clear with this? Not Chime only. Chime always clear, but the others?
Yes, doctor.
Okay, Hanis. Okay, good, Vinod. Okay. So these are some of the examples of the fillers and as well as the additives, no, that we can thank you, Alif. So and we can actually use and add into the polymer matrix. So example, fillers, I can say we learn about reinforcement is about to increase. When we say this material is a reinforcement, it increase the strength. It increase the strength of this what you call the strength of the material. Okay, but if let's say the filler that we use, it couldn't increase the strength, it become just like to reduce the cost, not in terms of strength, but in terms of, we call it the thermal stability or other type of property, that we cannot say reinforcement. The reinforcement is only related to strength, regardless of any type of strength, either it's tensile, fractural, impact strength, you know, something like this, no? Okay, so very good. So here we can add different types of this kind of reinforcement. Okay. Wait a minute. I need to like do some setting on this, what you call. Okay, so from here you see something like this, the additives. You can add different type of additives, no? Example, different, you can add anything, fire retardants. Okay, kids, we right now the current trend is because we are focusing on sustainable development goal. So this sustainable development goal, we usually will try to find something which is less harmful, less toxic, and less harmful to human being, or totally very friendly to human being. That is our maybe main goal, if possible, but sometimes it is impossible, okay? Depend on the situation. Then also good for environment, friendly to environment, okay? They are green. If let's say possible, we want to do want to use something which is green, that would be much better, okay? So you can get it something like this from here, no? additives, blah blah blah, and all these type of additives you can use. No, UV absorbers or UV filter as well. We can have something like this. Also, fire retardant. We can have. We sometimes there are some of the materials they are come from natural, and they have this function of fire retardant. Okay, aging stabilizer. So same goes to human being, right? Human being, we right now we want to be always young, and we don't want to be aged faster, keep younger. So like material, also we want it to be stabilized all the time, in a different type of conditions, in a harsh condition as well. So we can add the aging stabilizer into it, so that it will not be deteriorate. Okay, say deteriorate. Okay, it will not be fail so fast. No, okay, something is quite interesting. We also learned about this interface, right? In our previous class, physical class, we learned about interface. Start with F, and there's another is P. So both of them are quite important because they actually influence the physical and mechanical properties of the overall composite. No, okay. Okay, so I go for another topic. Okay, kids, I go for another topic. Can I go to toilet first? Give me. Okay, okay. I go to toilet for a while. Wait for a while. Okay. Okay, so we resumed the class. Let me show you the third topic. I'm sorry I didn't share this lecture note in the e-learning classroom. So after finish the class, or you want to have it now, I think I can share in the e-learning platform. Do you want it now? You want me to share it now in the e-learning platform? Okay, so So, okay, it's already in the e-learning platform, which is lecture 3, okay? Lecture 3. You can check now. Okay, huh? Okay, you got it, right? Okay. Check, no? Lecture 3. Okay, okay. So, right. So, let me continue this. The slideshow here. Okay. Okay. We'll start with this one. Okay. Can you all see that? Okay now? Okay, good. So we will continue the third topic. I will highlight some important part of it. You may find there are a lot of information inside. Okay. However, some of them are not important. It's just for your extra knowledge. That I mean, it's not important is not going to come out from the test or examination. Okay. Okay, so we learn about the we can actually add different type. Okay, the title of this is about the fillers. What are the types of fillers that we can add into the polymer matrix to form composites? So plenty of them. I can say from natural to synthetic. I can say all. It depends on how you will justify it, why you want to add into it, and how you justify it. Okay. Overview, just now I have mentioned. Okay. And we also learn about fillers can become into a different forms. Either it is organic, inorganic, synthetic, naturally occur, or it can be 0 dimension, 1 dimension, 2 dimension, 3 dimensions. All. Okay, all you can add. But in the topic number 4, in lecture number 4, we only focus about learning the fiber reinforced composite. Not the others, but just fiber reinforced composite, not the others. Okay. But here we just can get an overview picture of different types of fillers. Now, some of them can be used, can be treated as reinforcement, as you know. They increase the strength. Then we can say it is reinforcement. Well, and I also mentioned about in our physical class, I also mentioned about fillers. The initial idea of adding the filler is to reduce the cost. Okay, is to reduce the cost of the composite, of the polymer. Somehow, polymer can be very expensive. Can be very expensive. So, the manufacturer usually add the fillers, and then it would reduce the cost because they don't have to use much amount of the polymer in the process, and then to produce a product. Okay, and so example, we can use like sodium carbonate. Actually, sodium carbonate is very cheap and is plenty in Malaysia. Okay, then carbon black as well, and usually carbon black we use for tire, correct, and is pretty cheap as well. Okay, then okay, I want to ask a very simple question. Now we see this word like, okay, other fillers act merely by taking up the space, no? So there are some of the fillers when we add, they are quite heavy, meaning that the density is high. The density is high. So when high density occur, then we will face example like the composite would be higher, would be heavier. In terms of layman, we say heavier compared to the polymer alone. So this is also that we try to avoid, if possible, try to avoid. No? All right, so we come to this. No? Immobilization and possible orientation of the polymer segments. A, increase the glass transition temperature. Okay, so you see, what is meant by glass transition temperature? We do revision, we do a little bit of revision. Okay, can some of you tell me the definition of glass transition or not? I don't want Chai Mei, I don't want Jeff, I don't want Hanis. Oh, I don't want three of them. Okay, I want others to tell me the answer. Anyone? Maybe I can say no Google, perhaps. Material undergoes transition from rigid to glassy state. Okay. Okay. Well, that is so from rigid. What do you mean by from rigid to glassy state? Rigid. Can you define a little bit more, Zakwan? The glassy is not rigid. Rigid to glassy state. Glassy. Okay. From glassy to rubbery state. Okay. Okay. So where the transition is the temperature, right? We say the temperature. Glass transition temperature is a temperature, okay, where the polymer. So we only can find glass transition in what type of material? In polymer, right? Okay. So this glass transition temperature, in polymer, we have two structure, right? In general, polymer has two types of structure. One is amorphous, another one is crystalline region. They have two regions. So this TG only can found, this TG found in which region? In amorphous region or in crystalline region? A, amorphous, B, crystalline. Please vote. A, amorphous, B, crystalline. No Google, okay? Okay. Okay, Chai-Mei, amorphous, Jeff, amorphous, Ishwarya, amorphous. Okay, anyone have other, think of other answer? Can I have 2 more answers from you guys? Hey, wait, Jeff, how come you can say in between? Oh, that is pretty something I'm not agree. How come the answer can be in between? Okay, nearby. Thank you, Jeff. You sekejap kata A, sekejap kata B, sekejap kata in between. So what is the real answer? Can you make a conclusion? Finalize your answer. If you be like that, then it's very difficult. Okay. Who else? 2 more aside from 2 more. Two more. Who else want to give the answer? A, amorphous, B, crystalline. I want to wait for others to answer. It is okay if it is wrong. So I just want to, Alip, what do you think? Yes. Alip, you are quite passive nowadays. Before that, I met you, you are quite active in the class, Alip. So what happened to you? Or you are not listening. Perhaps you are go somewhere else. I'm not sure. See, this is a very simple question, right? Very fundamental. And it should be you have learned it since first or second year. I don't know if I keep give you the information bombard, but it seems you won't get it. You won't really remember. You will just like, okay, and then pass, none of your business. Okay. One more answer from you guys. One more answer from you guys. Okay, Mukri say A. Okay, very good. So now come with the conclusion is TG happened in amorphous. Okay, TG happened in amorphous region. So melting crystallization temperature happen in the crystalline region of the polymer. So that is why when you see you deal with a semi-crystalline polymers, then you will find all these 3 temperatures because they have all these structures. It has amorphous, it has also crystalline region. So you can have these 3 temperatures in one shot. Okay, so this is a special about the polymers that you won't get it from metal and ceramic. See, I just asked something like this now, very fundamental, right? It will actually drag me a lot of time. It seems the the foundation of the student right now is not that strong. If I ask all these very fundamental questions, then it will drag what I should share with you. You just keep repeating the simple things, which is you have been learned in the first year or second year. Okay. Hopefully, you're able to understand a lot after you graduate. Okay. Uniform distribution of fillers. Okay, now, I also mentioned about this, right? The uniform distribution of fillers is also very important. So, and the particle size is also very important. Either it's small size, big size, no. However, this is also very important. We have to, it will be good. The distribution of the particle will be very even. But unfortunately, it is not the case. It's not always very even, no? So somehow, sometime, okay. But we do our best, no, to let the distribution and dispersion of the fillers are even in the polymer. This is quite important, the uniform distribution. Well, all these are some of the examples. I think the properties that if we add the fillers, then it will help us in increasing a certain properties. It depends. And I will say the strength, regardless, is about reinforcement. So I will not repeat for this. High HDT is high density temperature. Let me check what is the meaning of HDT. Sorry, kids. HDT. Is a heat deflection temperature. Okay, heat deflection temperature is the temperature at which the polymer or plastic sample, the plastic material, okay, the plastic material deform under a specific load, meaning that you apply a temperature, on it. Example, like you do the tensile test. So tensile test in the lab, like in your second year, okay? So that's why I said, oh, you have to mention the test condition. Test condition is at which temperature, right? So then you get at this temperature about 25 degrees Celsius, example, that is a universal test temperature, okay? 25 degrees Celsius, you will get this result, the strength. But however, when you increase the temperature or when you reduce the temperature, okay, of the test environment, you can place the chamber of this, you can place the instrument of this tensile instrument in a chamber. And then this chamber, you can adjust the temperature. Then you will notice that the result you get will be different. So that is related to the heat deflection temperature of the material. Somehow, you are not really do it in your FIP, and I also know that because we don't have that facility. If we have that facility, then it will be very interesting, and well, we can just learn it from the theory right now. My sincere apology again. Okay, feel very sorry. Okay, then the fillers. Okay, kids, you know about this very well. All this I will not. Then later we will learn about a little bit of this, no? The creep, the fracture toughness, okay, and the fatigue. We will learn. Okay, we will learn. I think your test will not be covered this, but it will be covered under the exam. Okay. Considerations when specifying fillers. Okay, so in the industry, we usually have to consider a lot of factors behind what are the factors that it will influence the selection of the fillers and also the selection of the reinforcement. Of course, in the industry, we talk about money. This is number one. Okay, then only it comes to the properties. Okay, what are we focusing? What we would like to focus? So the property would like to focus either it is want to increase the like this. I want to increase this abrasion resistance. So if you would like to increase the abrasion resistance of the polymer composite, then we need to add the fillers which is give the high hardness. Okay, the filler has high hardness, and it would be good if the filler is only on top of this polymer. Yeah, so it will give a full protection to this abrasive properties to the polymer composite. And at the same time, it is lighter compared to ceramic. As we know, ceramic is very hard. Okay, ceramic is the hard, is like diamond. Okay, diamond actually is the hardest material in the world. Only diamond can cut diamond. So diamond is not only for decoration to make jewelry, but it is quite kind of useful material because of the high hardness. But anyway, it is quite fragile. So in this case, in order to compensate the brittleness of the ceramic, then we can incorporate it with the polymer. Then it will be very beautiful perform. Okay, so something like this, no? These advantages of fillers are usually attributed to the directional effect of fillers. Effects are magnified in one direction but lessened. Okay, so in general, we haven't talked about type of filler yet. No, this is only in general. Yeah. So here we can like categorize. No, this is in reinforcement. Okay, we can categorize the reinforcement into so many categories that I have been mentioned early of this topic when we enter to this topic, right? Okay, then in the fourth lecture later on, after we finish this topic, in the fourth lecture, we actually will be just focused on the fiber reinforced composite. And the fibers that we usually use in the example is the glass fiber. So glass fiber is the first, the most used, or we can say the first discovery of the fiber, which was used to be added into the polymer, and the polymer is a thermoset. And surprisingly, it will increase the mechanical strength. If you still remember, I show you in the lecture 1, the strength of this polymer composite with the metal, if you remember, right? So with this type of combination, the glass fiber and also the thermoset, maybe epoxy or polyurethane, surprisingly, the strength of the composite is much higher than the metal itself. And the polymer composite, such type of polymer composite, has lower density, lighter than the metal. So then it becomes an interest to these researchers and scientists to venture to discover more about the different type of polymer composites. No, then slowly they use different type of fibers. Example like this. No, Kevlar is the trademark of this. Actually, is one type of polymer. No, Kevlar is actually one type of polymer, but it has been trademarked, registered. I should put it R here, trademark. It become a bulletproof fiber. Then we have inorganic natural fiber, jute, silk. I think some of you use the natural fiber in your research, no, right? How many of you use natural fiber in your FIP? You can raise your hand, just raise your hand like this. Or give a reaction like thumb up, or yeah, raise hand or something. A lot, no? Okay. Okay, so I can feel there's a lot of you. I use some, well, this is the trend right now. We are using different type of natural material in the research. Okay, you know about whiskers? Any one of you know about whiskers? Whiskers. You know about whiskers? Yes or no? If no, just type no. I'm okay with that if you say no, no? Not necessarily must every time yes one. Okay, Jeff say no. How about the others? Okay, no. Okay. Okay. Whiskers in a simple way is like the what you call the cat. This part, the cat, and you have this you know, how can I explain it or describe? You know, you have this cat, the meow. Yeah, no, it's not short fiber. It's even shorter than the short fiber. I I think, but it is like the whiskers usually the end is sharp, right? Like the meow, the end is quite sharp, right? So this one we call whiskers. Well, sometimes like Chinese say, this is quite confused. We somehow will like match the whiskers with short fiber. She is right. So anyway, to be safe, no, we usually not there to say it is whiskers, then we say fiber. Usually, okay, to be safe. Okay, to be safe. So this meow type, right? Then the end of this bulu, like I can say, no, a little bit tajam, a little bit sharp, right, in the end. That you call whiskers. But the fiber not necessarily, right? Fibers not necessarily. The end part of this fiber is a kind of like sharp, kind of feeling. Okay. I Example, the whisker, ceramic whiskers are the most common reinforcement. So used in electronic, blah, blah, blah. Okay. The rest I won't touch more. Okay. Right. So you see, here is the example of the cross-sectional, we talk it, how we actually define it is fiber. So based on this one is aspect ratio, length versus diameter. Okay, you know aspect ratio, right? This is in inch, no? Sorry, this is in inch. 0.001 inch to 0.05 inch. This is in diameter. So in short, when we say the definition of fiber, when the aspect ratio, length per diameter, is this one in the range of 100, okay, then we can say it is a short fiber, lower than 100, okay. If it is higher than 100, the aspect ratio is higher than 100, then we call it a long fiber. So this is a definition. I think it's 50 to 100. 50, the aspect ratio should be 50 to 100. Then it's a short fiber. And if it is beyond the 100 aspect ratio, the length over diameter, then it all are considered as a long fiber. You call it continuous fiber. Okay, so particular, somehow it doesn't look like fiber, like satu keto macam tu, in a different shapes. Okay, then in general we say they are the particles. Okay. So whiskers, just now I mentioned to you, and whiskers, somehow this is talk about the ceramic whiskers now. So you see single crystal grown with near zero defect. This is ceramic crystal. This is ceramic whisker. So forget about this. We actually seldom use these ceramic whiskers because it's very expensive. It is single crystal, kind of very, very expensive. And we seldom use it now. And unless it is for a high advanced product, high end, we call it like high quality, high end type of product for high end application or advanced application, then we only use it. Okay, It differs from particle, blah, blah, blah. Okay. Matrix, metals, ceramic. So this one is about the ceramic. Okay, so this is the table. To summarize, no, different type of fillers. Okay, with their property. Okay, and related them with the applications. So, Dr. Aslin, she will actually further share with you the applications of polymer composites. No, she will share with you in this part. So this is, I'm gonna just like let you see the clear picture. So make it into a table form. This I adapt from one of the, I think, buku or I think from the book now. So it's about this, about the transparency and blah blah blah, and for your reference, because this part Dr. Azim will teach you. And okay, and they are the, what you call it, are they the fiber, are they the glass fiber? Okay, there are different types of fibers. Okay, different type of fiber. Carbon fiber, which is quite popular right now. Carbon fiber. Okay, just a little bit of sharing. Carbon fiber in the Western country become quite is a very popular material, and carbon fiber is quite expensive actually. It depends on the manufacturing method and the raw materials that it obtained from. And when I was in Australia in 2019, the university that I attached, they have a one carbon fiber institution, just focus on producing carbon fibers for advanced application. And it is quite kind of a secretive place, because the carbon fiber they produce is for the military application. You know, military, like soldier, those. Yeah. So I cannot enter, actually. Cannot simply enter without, a concrete reason that why you want to visit to that institution or to that institute. Yeah, research institute. So I stay there for 6 months. I don't get the chance to enter, indeed. Because I don't have reason, I don't have collaboration with them. So Masale use a lot of carbon fiber in advanced application. Okay. Influence of reinforcement. Hey, so kids, you see these, no? Some of the examples. Actually, there are many factors will influence the properties of these fillers or reinforcement. So depends on its, you see, this is the arrangement of the fiber. You're gonna to learn these different type of arrangement of fiber and give different properties from Dr. Astin later on when you learn the lamella composites. No, I'm not going to do much about this. So the arrangement of the fiber, okay, these are one of the factor. And of course, whether the fiber is in what we call in a short fiber or long fiber, it also will influence the property of the composite. And the types of fibers. Okay, so from here you will see this is a short fiber. So usually short fiber will give the lower strength, and long fiber will give the higher strength, provided everything is in the manufacturing process is in a proper condition. So you will have all these, no? And the types of fiber, of course, carbon fiber is expensive. Natural fiber is cheaper. Example, you can use jute, bamboo, kanaf. We have a lot in Malaysia. Some of the researchers, Dr. Rosyanti is using the kanaf fiber, no? A lot. And then other type of fibers naturally occur. Okay. So, guys, this one is important. Talk about glass fibers. Okay. So, let's example we have we divided it into, I think, 3 types of glass fiber. Okay. Then of course this is the basic type of fibers that It has been used since long time ago. I think 50 years at least. 50 years at least. No, it comes with a different types. Glass fiber come with a different types. No, from the cheapest to the some of is quite expensive. Then advanced fiber. Advanced fiber example boron. They this type of advanced fiber usually they give a higher strength. They give higher strength compared to glass fiber. So example, boron, silicon, graphite. Graphite is the recent, not recent anymore, but is one type of the advanced fiber. Like you make graphite fibers, no, aramid fibers, yeah, polyamide, nylon. These are all the advanced fibers. Okay, I pass through this, no? These are the advanced fiber. Example, we will focus on this glass. Okay. Okay, so glass fiber, what are the benefits of using glass fiber? It gives all these type of benefits. Okay, and we also have to be very careful when we deal with fibers, regardless, no, regardless glass fiber, carbon fibers, whatever type of fibers in the industry. So what do you think we have to be careful? I mean, in terms of when we deal with this type of glass fiber, uh, it will be what? The glass fiber will be easily what? Can someone give example? The glass fiber will be easily what? Anyone? When you deal with glass fiber, you have to protect yourself, right? Inside the nose. Yes, yes. Okay. So when we use not only the glass fiber, any types of fiber. So in the industry, we have to like ensure we protect ourselves very well. We wear masks. Okay. Then it won't like fly, it won't go into our body, you know, and then it will affect our health. Okay. So it's quite important. Okay. Now go back to this. Glass fiber can be divided by three types. C, E, S. C, E, S. Okay. C is the cheapest. C glass, E glass, S glass. Okay. So it seems the internet is somehow not really stable at your place, no? Okay, so glass fiber, you will see a lot of glass fiber in our daily life, like our roof, macam plastic ceiling not made of glass fiber, no. Something in our school, you know, the ceiling, no, is made from glass fiber, the asbestos together with the glass fiber, no. Then glass fiber is low cost. Example, S class is low cost, corrosion resistance. Well, usually the cost is quite low, and of course, glass fiber divided into short and long as well. Not only the classes, the classification of the class, but they also have long and short. Okay. And what are the disadvantages? They are quite low in strength. I mean, compared to carbon, aramid, those advanced fiber for sure. Okay, they just about the strength. Okay, the strength is quite low, so that's why the selling price is also low. Sorry, it's not S class, it's E class. E class is the cheapest. Then you can always find it in the electrical application. Okay, kids, I won't really repeat this. Let me check about this now. Wait, okay, so glass fiber. Okay. Oh, okay, so here, sorry, it seems like the notes is a little bit messy, no? So here are the categories of the glass fiber. Start from E, the cheapest and the popular, and E meaning electrical implies, no? So it consists of this one. The major ingredient is the silica, okay, alumina, calcium oxide, and this is not boron, but beryllium oxide, okay. S class, S means strong. If I'm not mistaken, like S means strength, okay, strength. S means strength. So strength, so you will know it's a little bit of expensive. Okay, C means corrosion. So it has a high chemical resistance. Then we call it, this is a C glass fiber. Kids are not able to finish by time, okay, by this topic. Anyway, we have E, S, and C. E is electrical. S is because of its strength, okay. C is because of its corrosion resistance. No worry, I will not ask, I think I will not ask this about the glass fiber. Okay, so we can use different type of polymers, and then add the glass fiber to add the glass fiber into different type of polymer, regardless is thermoset, thermoplastic, as well as elastomer. All we can do. And you will learn this, the laminate structure sandwich with Dr. Aslin. Okay, so I will stop here. Okay, I would like to discuss with you. Are you free today in the afternoon? About 4:30 to 5:30. Can we have one more hour to meet today? 4:30 to 5:30 to finish up this topic.
Sorry, doctor, we have class during that time.
Then what it will be your free time later today? Can give me 1 hour, 1 more hour to be with you today. 1 more hour. Cannot It's full, is it? Esther say after 5. Oh, after 5. Okay, meaning that will be in the evening. Okay, can we do it? Oh, evening, okay. Okay, so can we have the glass? Can we have our glass from 9 to 10? Or it will be quite, or 8:30 to 9:30. Maybe 9 to 10 is so late lah. How about like this, 8:30 to 9:30? Okay or not? Yeah, to 9. Yeah, 1 hour. 8:30 to 9:30. Okay or not? 8:30 to 9:30. Is everyone okay? Okay, no? Okay. How about the Malay student? Okay, honey scan, the boy, okay, no? Okay, so I will see you like 1 hour. Maybe it will be a little bit maybe less than that. Hopefully, we will finish this topic today, and then we can continue the new topic tomorrow. So, and I give you the quiz as well. Yeah. So we do it tonight. 8:30 to 9:30. We'll start our class at 8:30. Okay. Then hopefully I don't have to take 1 hour. Perhaps it's just like a 45 minutes. No. We use the same link that we use now. Is it okay? The same Google Meet link. For the class later. Okay, thank you, Alif. Okay, so see you guys later, 8:30 in the evening. Okay, so tada. So I will see you later. Okay, nah? Okay. Right. Okay. Yeah, so I will off the card. I mean I off the link. Okay. Yep. Okay, bye bye. Bye bye. Okay. See you later in the evening.